Hello and welcome to the eighth late night programming stream. I am Luca, and today we will be working on a small little game called Asteroids in raylib. Also, the music's super duper loud. Turn that down. I always forget to do that. Right, so today we're going to be creating asteroids. If you've never seen what that game looks like, I had this cheat sheet open for raylib because we will be needing this in a second. But here's how asteroids looks like. I keep spelling it wrong. Asteroids game. The link to this Wikipedia is in the description, but it's a very old and very classic game. Basically, you're a little triangle ship dude, and you shoots asteroids coming at you, and they break into pieces. So let me see if I can find a good. But basically, these bigger asteroids break into smaller pieces, and those pieces you can break, and that's how you kind of gain points. That's the entire game. Today we're gonna just do the very beginning of it. We're gonna create like a little ship guy. He's gonna be able to move around. He's gonna be able to shoot, and then the asteroids will also be like, well, instead of being like these crazy shapes, they're really just gonna be like squares. And we're also going to add possibly like a score somewhere, just so we know how many asteroids you've destroyed. I think that'd be kind of cool. I think it'll be kind of neat to give a shot. So cool. Let's get started here. So here is the agenda for today. Here's how I'm most likely gonna go through everything. Not too much, and I'm hoping it'll just take the 3 hours that we're on stream. So all right, let's get started. So since we're doing this in raylib, we already have that installed, so I'm pretty sure I can just start a C++ project and should be good to go. So let's do that real quick. Asteroids.c. There you go. That's going to be the entire thing. We'll start off with like a little hello world program, just so we can set up our compiler and everything. So let's do that real quick. RV 0. Actually, let's do 42 420 69. Woohoo, let's go. Okay, I think that's good to go. Then we're gonna write our little compile script. Actually, we could use CMake, I guess. I think CMake will be fine because I'm not sure what other system to use really. So let's create a quick. Do we even have CMake? We do, perfect. So let's quickly make a CMake. I think it's CMake lists. I don't know if it's list or lists, but I think it's that. And I think I have to set the CMake version, so I just need to say CMake template. And then after that, I can just CMakes with an S. Okay, so let's take this. I think we're at 3.5, so I think we could do that. All right, and we're gonna do a little project here, project CMake template. So we're gonna call this asteroids, just like that. And then we're going to add a library. So I think to do that or actually let's make the executable. So let's do that. Or is it add executable? Add executable like this. I remember, yeah, I think it's like that. Cool. Add executable asteroids.c. So that should be good to go. I think that's all we need to compile at the moment. And I'm also going to set the C flag to be C99. So I'm going to take this. How do I set the C standard actually? Set C standard C8. There's a lot of things that I just forget. I always have to look these up no matter what. Okay. I want C99, so C standard. Okay, so C standard required. Okay, so this is the property I think I have to set. So yeah, I think let's just copy this guy, copy that guy, put that in here. And I think it's just this C standard, and this is going to be C99. I think that's it. Yeah, I have to do C99. C99. Okay. I think that should do it. Let's find out. So we create a little build folder here, there, and then we do that. Okay. Cannot find. Okay, it's because it spelled the source file wrong. So let's quickly fix that. See bliss. Yeah, I keep spelling it ioids instead of asteroids. I don't know why I keep doing that, and I keep spelling it wrong everywhere. C center set to invalid value, nice C99. To do this, I don't know. I literally have no idea how this works. Okay, so I think then it must be that we have to do it like C property. If the value does not result in a compatible, use a previous standard flag will be added instead. This means using okay. Okay, I think it's that maybe. Let's try that real quick. So std equals 9.c. Does that work? Incentive invalid value. C99 standard. Oh. Oh, it's this. Oh, it's exactly what it said. Oh, I understand. Okay, I'm just an idiot. I'm sorry, guys. All right. Let's take this guy and add this guy. Okay, does that work? Cannot find target TGT. Oh. Asteroids. There we go. I'll do it. Cannot find target asteroids. Probably it's not been made yet. Because this has to be up here. Sweet. Now we finally have a little file. I think we can do make. Perfect. And then asteroids. Alright, perfect. Alright, so now we have 42069. Now we need to add in our... Now we need to add in the dependency on raylib. So I think we can just do add... Let's say it's add library. No, add library is for creating a library. I think it's target add library. Add library. Yeah. How to add library. How to include. Sorry, include. How to include. Target link libraries. Okay, I think that's it. Target link libraries, and here we put asteroids. Okay, we put private in here, and we put raylib, just like that. I think that should be okay. So let's do a quick remove of the CMake cache. So try that again. Make. Okay, so apparently it did just fine. And then let's go ahead and open up Asteroids. Let's see. So now let's write in. So now let's write in the code to start up a window in raylib. So that will be window. Why is that not working? Window. I think we put in a name here. Let's call this Asteroids. And I think we also put in the width and height here. Let's do 800 by 600. And then I think we have to do something window here. Let's check the cheat sheet real quick. Cheat sheet, close window. Close window. I think that's it, right? and then window should close. So let's do while window should close. We will do in draw and draw, and here we will do, let's see, draw text. And what's the thing for this? Draw text, draw text, draw text. So that's a character. Let's do the same thing we had before, 469. Hey, what's up, fam? Sorry, I didn't see you there. I'm making a simple text editor right now. Cool. That's a project that I wanted to get into as well. Sorry I didn't see you there. My bad. I wasn't expecting people to just come in, and it's gonna support syntax highlighting and all that. Cool. That's really awesome. I think it's a really cool mini project to do. I mean, I'm not sure how many it'll actually be, but it's a really fun project, I think. And let's put this at 400. Font size, I guess 20, and then color. Let's see. Does that compile? Didn't like that. Okay, so let me quickly see my raylib. Let's see. Oh, this is a make file. Yeah, that's a make file. I just want an example of how to include it. I don't use CMake that often, so I kind of want to get with it. Because I want to make a decompiler for the Pokemon scripts. So turning the Pokemon scripts in a programming language and then compiling again. Cool. That sounds pretty cool. It's pretty neat. It's pretty neato. Let's see. Oh, they use this, which I don't want to use. Okay, so I think what I'll do, honestly, for now, just to get ourselves going, is I'm just going to go ahead and clone raylib here, and then just do and just get the dependencies that way. I think that should be okay. So clone, yes, github.com, ray75, raylib, and then we'll do that to 1. Okay. It's going to be a bit of a pain because there's a lot of rules, a lot of things to handle. Yeah, it's going to be a lot, but I think it's a fun project. I wrote a while ago when I was an intern at a company. I wrote a syntax highlighter for Lua, which is like it's a dynamic programming language, and that by itself was already pretty difficult as a beginner, but it also helped me learn a lot. So it's definitely a cool little project that will definitely elevate your programming knowledge, I think. There's like 1,000 functions in the Pokemon scripts. I bet there's tons. Man, this is taking quite a while to download. We're at 77 kilobytes a second, even lower now. So that's why raylib is taking a bit. But it should be okay. Guess I'll chill here while it downloads. And I need symbols, the type of parameters from all of them. Yeah, it just sounds like it's gonna be a lot of work. Maybe you can find a way to like automate the process, like write a program to help you automate that kind of stuff. I think that'd be kind of neat. Why is this taking so long? Oh my god. Okay, you know what? I have raylib, I think, in a different folder, so I'm just gonna quickly copy it here. Jeez. Here we go. Okay, so now I have raylib in here. Yeah, and then I'll go into here, and instead of doing target link libraries here to raylib, I will caps lock one. Yeah. So let's do. Actually, I need to see what raylib actually wants. Let me see CMake. Okay, so it's just raylib. Cool. So let's go to CMake lists and let's add a little section here for raylib. And here we will add subdirectory, and we're gonna add there we go. So then after that we link the libraries. We also need to include, I think, target include directories. Target include directories, yeah, and then asteroids. And private, and we'll put in here, I think it's project source. What is it? Project sources. Where is it? Where's the thing for this? Unfortunately, all the parameters and okay. Out of curiosity, how would you render text in a text editor, and how would you store the data? The same goes with symbols. They're also stripped. What do you mean? Like, how do you render text? Usually, what you do is you take the font, and then you have to use shaders to kind of get the UV for the letters you want to show. So it's a whole little thing. It's not too difficult. There's a book on how to do this from scratch. The book on OpenGL on graphics programming, and it'll show you how to render text. But yeah, if you're doing it from scratch, that is, then you'll need basically to read texture data and use a shader to show it. Yeah. Okay. Project. Is it just project source? I want to say it's like that. Raylib source. There we go. So that should include. Yeah, that should include the include directory for raylib. And I don't know if I need this, so I'm gonna take this out. I'm gonna move this up here just to keep things a little clean. Alright, and now let's go into the folder. I'm gonna delete the cache file, and we're gonna try this. Okay. Default build type is not set. CMake build type. CMake build type. CMake build type. It's not set anywhere. Okay, well, that might be for. It might be for. Yeah, I don't know why it's set. Alright, let's make. Or make. Huh? Oh, CMake. Make. Alright. So now we're compiling raylib, and we are on our way. Okay, did you mean end drawing? Oh, okay, begin drawing and end drawing. Okay, so let's do that for the asteroids. Begin drawing and drawing. Let's make. Oh, it's window height. It's the dimensions first. So let's take this and move that here. All right, cool. So now we have asteroids going, and we have 42069 in the middle. So we're on our way to creating asteroids. Cool. Okay. Yeah, I have shaders already. Cool. But the text I rendered so far was a lot simpler. It was just some loops, but I can't loop over every character here. So I need to make some kind of clipping rectangle and break out of the loop. So, okay, I'm gonna quickly find you the link to this, because it's just not possible for me to explain this in here just by like talking. So there's this OpenGL book which will teach you the same thing. The book of OpenGL, something like this. Book of OpenGL, something like that. And this one, yeah, here it is. Learn OpenGL. And this teaches you how to do text rendering, and it should teach you in general how to do it. So yeah, I should teach you in general how to be able to write that. Let's see. Oh, I got a little raid by TCap1. Hey, what's up, TCap1? Thank you for the raid. That's cool. Hey everyone, the people that came in. It's interesting. It's awesome. I'm working on a very. I just started, and I'm talking to Fan here. He's having issues with text rendering, but I'm working on a small game project in raylib using C. We're gonna be making asteroids, at least a little bit of asteroids. So if you're into that, stay along and watch. I do these streams Monday through Thursday, every single day. Every Monday to Thursday, sorry, from 7 p.m. to 10 p.m. EST. So if that's something that seems enjoyable to you, please come along and join me. It's just a fun little time here. All right. So in here you can find like this. It's a really good tutorial for learning about graphic programming. It's an OpenGL, but you can see how to render text in this, and it like it makes it really like simple to do it. Or, like it gives you a good idea how to do it. So I think it's somewhere in here. Let's see, in practice, text rendering right there. So I'll send this in chat. Here you go. That was for Fan. I'm using right now NeoVim. So right now we don't have much going on. I just started the Asteroids project. I've been sort of setting up the project for it. But here it is. I literally just got a window open in raylib, so we like pretty much like just started. But yeah, I'm using NeoVim. All right, so I guess the first thing I want to do is I want to write. I want to make my little player guy, and the player is just going to be a triangle for now, a red triangle. And honestly, it'll probably be like that for the entirety of the project. I want to kind of keep it like very simple graphics. The graphics are going to look kind of like, let's see, Asteroid game. Yeah, it's going to be kind of like this, just like line drawings. I think that'll be kind of interesting and keep a cool little retro look. So yeah. All right, so let's go back here. Get a little player guy. A little struct for him. That's player. And in here we will store its position for now, just its position. Cool. And right over here we're going to initialize him. Actually, we'll give it the player dot underscore t. So player, go. Set this to 0. And I guess I want to set its position to. I think I kind of want to set its position to around the middle of the screen for now. There you go. Should be around there. And down here, instead of drawing the text, we're going to draw a triangle instead. So draw, let's cheat sheet over here. I think it's draw triangle. Draw triangle, right? So we're going to do this. We might actually use a different function, or we might just use like draw, where's the lines? Yeah, like draw line here instead, because we do need to rotate it, and I think it'd be easier to rotate it if we just had lines to do that. So I'm gonna do it that way, I think. Just drawing a couple lines. I'm glad you're helping out Fan here, TCap1. All right, so let's do that. So draw line V. Okay, so we'll need 3 of these, and for now I guess I will just use the. For now I'll just use this. I'll just use the regular triangle, just to keep it simple for now. The regular triangle draw call. And I think what we'll do is, how does this make the triangle? I guess what we'll do is we'll make the very top, the tip of the triangle, like the position of the player for now, instead of the middle. So, actually, we could also make the middle. Let's do that. So this is going to be the tip of the triangle, which is going to be the player position. And then this goes counterclockwise, so this is going to be the left side of the triangle. And this is going to be the player position. Plus negative, let's say 10 for now. 10 on each. So it'll be negative 10 and then 10, so it should be like down and left of the original point. And we'll do the right side too. To get something on the screen. It's 10 and 10. Alright, and then we got P1, right, and what was the other couple of, what's that? There we go. Alright, so let's see if this draws. Let's do a quick little build, and a bunch of errors. We got a little open bracket here. Oops. Oops. Make. Vector 2 add. I think I need ray math for that. That's probably why. Raymath.h. Okay, make. Sweet. Alright, so now we should have a little triangle in the middle. Nice. That's neat. Cool, 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 cool. So now let's do that same exact thing, but now we're going to draw lines instead, so we can more easily rotate it, I think. So to do that, we will need a for loop here, or we'll just straight up draw the lines inline it. We'll straight up just do 3 of these to create it. So let's do that. Line V, and that's start to end and color. So first we'll do from position 1 to left, and we'll call that red. We'll do position 1 to right. We'll also make that red, and then we need to connect the bottom 2 lines. So then we got that. All right. Okay, and now let's do a little build here. Cool, and that should be perfect. That's exactly how I want the player to look like. Sweet. Okay, there we go. Next thing I want to do is I actually want to put this all into a function. So now I'm gonna finally create a little function called draw player, and inside of this we'll just put in the player, and we'll go ahead and copy all this. Draw player. We'll put in the player in here. We'll put in the we'll put in the pointer to the player instead of the actual player. There. Indented back. Pointer. So now we should just be able to draw it with that inside that function. This will be useful because I'm going to add keep the wrong thing. I'm going to add like an extra rotation parameter here eventually, so that'll be useful for that. Or we could probably add it to the player on its own, so everything is contained within there. Make. Oops, what did I do wrong? Over here. Accidentally deleted that. Make player dot position. Right, because C wants to use this little arrow guy whenever you're dealing with pointers. So let's do that real quick. Make. Alright, so now we have the same exact thing we had before. Cool. Alright, so now let's try to make it rotate. So I'm going to add a rotate parameter now. Rotation. And to rotate it, I think what I'll do is, well, I'll have to create. I think, how many vectors? 2 vectors for the triangle. So let's create 2 vectors for the triangle, 2 vectors that we can rotate. And I guess what we'll do is we'll make it from the player position, from here, from like the tip. So it'll be rotating on the tip of the triangle. That's what it'll rotate. Okay. So to do that, I'll need, instead of doing left like this, we're actually gonna do it like this. So it'll be vector 2 subtract, and we will subtract. Actually, we can just write the vector like this. This is relative to our player position, so we can just do it like that. Yeah, I think we'll do that. So we'll do it like that. And then instead of doing this draw left, draw right here, from P1 to left, we will do from P1 to vector 2 add left to 1, like that. And then we'll do vector 2 add right to P1. And here we will do vector 2 add left to P1, and vector 2 add right to P1. Usually I would cache these operations here, but they're so, like, repeating them twice here, like here you can see I'm calling this add function twice. It's very minimal, and I just don't feel like creating the variables for it, so that's why it's going to be like this. But now the cool thing about this is that we can take this left and right vector and we can rotate them. There's like a raylib function to rotate these. So let's do that. Let's do, so for now, their rotation is going to be 0. But in here we have to actually rotate this left and right vector. So I think if we go here, it's another one I have open, there is a rotate. Yeah, here we go, vector 2 rotate. So all we have to do is put an angle. I don't know if this, I think it's degrees. I think everything in raylib is by degrees, but I guess we'll find out now. Okay, let's rotate, and we're going to rotate this by layer rotation like that, and we'll do the same thing on the right there. So right now when we draw this, nothing should change, except that's wrong. So let's see what went wrong. Oh, there we go. So let's do that. All right, cool. So we got the same thing. That's good. And now we can try with different rotation values and see if we can actually see if it actually rotates. So let's do 90 degrees. Let's do a quick build. Asteroids. Cool. So it's sort of, this is more than 90 though. So maybe it's not in degrees. Maybe it is in radians. So I'm going to quickly define pi up here. And I'll just do 3.1415. So that's good enough for me. And actually we'll define tau as well, just because it's a nice value to have. There we go. That's pi times 2. There we go. And here we will do, let's do yeah, pi divided by 2. So that should be 90 degrees. So oops, run it. Okay, so it is in radians. It's not in degrees. Okay, that's fine. All right, so now what I want to do is I want to make this player guy rotate towards my I want it to rotate towards my what's it called? Rotate towards my mouse, but I also want to make it rotate from the middle. So to do that, I'm gonna have to do a slightly different thing for drawing the player. So I'll do that right now. So to draw the player, we actually have to define a top vector here, and everything's going to be relative to the middle. So let's do that from here. So from the middle of the player up 10, that will be the top of the triangle, and from the middle, if we move 10 to the left and 10 down, that's going to be the left side, and then yeah, so that should be okay. And now we'll actually, and also you have to rotate the top vector now too. Rotate, top layer, rotation. Okay. And from there, what we have to do is actually create our 3 points. So now that we have a few more variables, I'll just create 3 points for them. So this will be top plus player position, because they're all relative to each other. Oops. So, ooh, what did they do there? Oh my god. Okay. So that's P2. We'll call this top, left, right. And this is left. And this is right. There we go. And then we'll draw the lines how we need them to be drawn. So this one goes from the top to the left. This one goes from the top, the top to the right. And this one goes from the left to the right. There we go. This has to be like that. This has to be like that. There we go. Okay. So that should rotate. Our middle point should now be the middle of the triangle. Let's see how this looks. Rebuild. Oh, I can just use pi. I think, oh, raylib has a pi. That's cool. So I actually don't need this. So thank you, raylib, for providing the pi, and it's a nicer one. Okay, great. So now we're drawing a different type of triangle, and it's going well. Okay, so now we're finally going to take our mouse input and figure out how to rotate it towards that. So let's open up asteroids. Let's see. And here what we'll do is we'll need to get the mouse position. So let's get the mouse position like that. And we also need the player position, and we need the vector between them too. So to get to that, cursor. So this is going to be the vector that goes from the player to the cursor, and that's going to be mouse position minus player dot position. And now what I want to do is I want to get this angle in. I want to get this angle for our, like, how to rotate our dude. So to do that, I will see if raylib has, yeah, so this is what I want right here. Vector 2 angle. Calculate the angle from 2 vectors. Okay, that should be okay. The issue with this, though, is that it could go either way. Like, you could have a vector like if this is the v1 and this is v2, then this will be like, I don't know, like 45, but also here it'll be like 45. And so I'm hoping it gives you like the right direction. I guess we'll find out. Vector 2 angle it is. So this is So I want to do it from the like from pointing up. So I guess it'll be like this, something like that. It's going to be from this one, which is pointing upwards, and to cursor, which is whichever direction the cursor's in. And for now, what I'm going to do is I'm going to draw it on the screen. I'm going to draw the angle so I know like what it is. So draw text, and here I will put, oh, I'm going to need a way to add stuff to the text line here. Does raylib have an easy way of doing formatted text? Raw text, oops. Raw text. Okay. And it doesn't, so I guess we'll have to use sprintf. And I will just create a little buffer here for it. So this will be our angle string. And it'll be 256 characters long. And I think we can do sprintf, and we'll put angle string there. And we will do that. And we will do angle. This is an F, I think. So that should do it. And then here we will just put an angle string, and we'll do the other parameters. So we'll put that in the middle. Actually, we'll put that a little high up. Actually, yeah, we'll put it at 0, 0. I think it'll be okay. And we'll make it red just so it stands out. And we also need the text size. I think that's how I do it. That's how to do it. And before I print this out, I forget what's the formatting way to do this. I think it's like this to show like 2 decimal places, but I can't remember. Format text or text format, I forget. Oh, cool. Let me check the cheat sheet real quick. Text format. Oh, here it is. Cool. Cool. It does pretty much exactly what I needed. So I guess we'll use that. I wonder how this is garbage collected though. Do I need to take ownership of this? Do you know if I have to take ownership of this string? TCAP? Oh, okay, great. So I can just use it. Cool. Raylib is cool. That's neat. Just go ahead and copy this guy. Instead of having to do all this, I can just do text format. And here I'll just do 2F, and I'll just put in the end there. I think that should be okay. Was that it? That seems to be it, so let's give it a shot. Oh. I guess I'm used to operator overloading, so let's fix that real quick. Vector to subtract. Cool, there we go. Alright, so now we have, I forgot something really important. To clear the background. Alright, and we'll guess I'll make this black. I like the color black, okay? And now we can make and build. Okay, cool. So up here, 0, that makes sense. Okay, so it does do negative values, which is what I wanted, and it also is in radians, as I can, because down here 0, and then down here it's around 3.14, which makes total sense. The function contains something like a bunch of buffers, cycles through and returns one of them. Oh, perfect. That's cool. It's a pretty interesting way of doing it. Thank you, K-Trap. Okay. Okay, so we're pretty much done with that getting angle function. So let's go back here, and I can now, instead of doing this, I can actually put the angle into the rotation of the player like this. And that should be good enough to have the player rotating towards the cursor, I think. Let's try that out. Nice. So there we go. We have a little rotating player towards the cursor. That feels pretty good. That's kind of neat. All right, so now what I want to do is I want to make the player move towards the cursor. So that should be pretty easy as well. And I want to also do with like an acceleration, and yeah, so it kind of like moves little by little. So we're just going to create 2 extra parameters here. We'll call this acceleration. I spelled that wrong. Acceleration. I think it's like that. Man, I cannot spell. And then we'll do velocity. Okay. So now instead of here, we have to, let's actually initialize now that we have enough stuff going on with the player that I kind of want to have an initialization function. So I'm going to do that here. Cool. And then we'll go ahead and copy these guys up there. And here we'll do init player. And here we'll put in the player. There you go. Cool. And then we take this guy, we leave him up here. And then we have to switch the we have to switch what we're doing with this. So like, there we go. Okay. And I don't know why that happened. There we go. All right. So now we can do player dot. I guess the acceleration does not need to be a vector. It's actually just going to be that, a float. It's really just going to be a scalar value that we add to the acceleration in the direction that we're pointing the mouse at. So we'll make this, how many pixels a second should we increase it by? Let's start like 10. No, yeah, 1. It'll increase by 1 pixel per second squared, I think. And then we'll do velocity, which for now it'll just be, I think there's a 0. I think there's a 0 in raylib like that I can just use. So I'm going to try that. And if it fails, then it fails. Okay. And now I also want to add a max velocity. So I'm actually just going to put that as a define up here. So max player velocity, and that's going to be equal to, let's say, 100 pixels per second. So around there. Cool. And now we'll have to do 2 things. Well, the first one is we have the 2 cursor, so this is going to be the direction that we're moving in. And we have the velocity, which is what we want to add to it. So let's do that. Player dot velocity is equal to 2 cursor. And here we're going to actually scale this. Actually, we're going to normalize it. We have to normalize this. I just thought about that. So this is going to be normalized. Is there a normalize? Yeah, normalize. I thought it was normalized though. So there you go. So normalize this dude. And I guess we should only do it if it's not 0, but I'll worry about that later. I'll put that into do. Make sure to cursor is not 0 vector. Okay. So now we have the velocity that we've normalized, the direction, and then now we can scale this by our, what are we going to scale this by? Our acceleration times, it's going to be get, there's a frame to get the frame time. Get frame time, there we go. It's good. Get frame time. So that should add a tiny bit of acceleration to the velocity every frame. I'm not sure if I have to do actually this, like double it up. Actually, I don't have to do it. I understand, because I will do that when I add it to when I add the velocity to the player position. So I think we're good on this. Here we're adding a little bit of velocity to, well, this scales it. Now we actually have to add it to the velocity. So let me do that. 2, and this will be player dot velocity. Okay, so because there's so many values here, I'm actually going to create a couple variables for these. So acceleration, let's call this A actually for now, and we'll give it a better name in another time. Frame time, there we go. And then we also have to do the direction, so we'll call this direction, which will be vector to normalize to cursor. There we go. And now I can go ahead and do this here. Oop, I deleted way too much. There we go. Direction, and then let's delete all this here. Scale it by acceleration. And then we add that to the player velocity, and all that gets put back into there. Okay, that's good. And now we have to augment the position by that. So this is equal to add to. You have to actually scale this by. You have to scale the velocity by the frame time. Okay, frame time. And then we have to add it to our position. Okay, so this should move the player towards the cursor. Let's do a quick build. Okay, so where am I forgetting? Oh, here. Right. So we'll change this from player dot to player arrow. Okay. Okay, let's make acceleration. Right. So acceleration is not a random variable I can just use. It's actually part of the player structure, so I have to make sure to do it that way. Yeah. Okay, make again. Alright, asteroids. So it's not okay, so it's moving, but very slowly. So let's increase the acceleration for this. So let's do that. Let's increase it by 10 times. So let's see how that looks. Alright, so it's kind of going cool. So it should stop, and it should go towards the mouse. Cool. And now it should point in my direction. It's just there's too much. The acceleration is still very slow, so that's why. Cool. Cool. Alright, so let's make it a little faster now that we know it's working. So instead of 10, I think 100 should be okay. And then we'll also let's cap the velocity. So to do that, we'll have to yeah, okay, we'll just use an expensive. Yeah, we'll use an expensive algorithm for this. Oh, not algorithms, expensive function for this. So we'll just go ahead and get the distance, get the squared, the length of it, which involves a square root, but that should be okay if we don't use it that often. So let's get the length of our player velocity, and if player length of velocity, let's say it's greater than our max player velocity, Then we're going to set the player velocity to the player velocity normalized. Normalized also uses a square root, so but it's a necessary thing that we need to do for getting the direction. So yeah, so vector2 normalize will normalize the velocity, and then we'll multiply that by this velocity in that direction by let's do max player velocity. So if the velocity goes over that, then we'll just set it to that. I think that should be okay. The other thing we can do, which might be a little nicer, is only add the acceleration if it increases it more, then only add the acceleration if it's still under the threshold, but I don't want to do that. I think it's better like this. Okay, so now let's see if this works. Oh, oops. What did I do wrong? 64. Scale. Make asteroids. There you go. Cool. So now we have a little guy, and he doesn't go faster than how much? That's the maximum speed, which is pretty slow. It's pretty slow. So let's make it a little bit faster. It's cool that it works, but I also want to make it so we'll do two things on this round before we test. But we want to make this faster, so let's make this 4 times faster. And we also want to make it so what was it going to do? Oh yeah, click. I want to make it so I can click instead of I want to only add the acceleration if I click. So let's do that. I think we could do it here. We can do it on here. So let's do if get is mouse button pressed. I think it's like that. I'll just check. Is mouse button pressed? Okay, and I think we can do left mouse button here. So left mouse button. Man, I wish I had the autocomplete, but I don't know what happened to it. I don't feel like fixing it right now. So we won't have that for this stream. So let's do that. There we go. This is to get this is to add the acceleration. And I think it's not pressed actually. I think it's down. There we go. Okay. Okay, so now I totally forgot what the... Can I go into this? I think it might be... Is it GD? No. How do I go to this file in Neovim? Oh well. Let's go to raylib examples. I know they'll have a mouse example here somewhere. Probably... Where's a good mouse example? Okay, I think it's this one. Yeah, so there we go. So we have a clicking example. Mouse button left. What did I put? Oh, left mouse button. Mouse button left. Okay. So if that's down, then we will add that acceleration. So now it should be a little nicer in this. Yeah, so now it's not moving. And if I click, yeah, nice. It stays at a certain velocity. If I click, that's neat. So it kind of slingshots. Cool. That's cool. So this is like a way, this is just a better way of controlling it, I guess. It's kind of neat. Okay, so now we have a little die that moves around, which is kind of neat. That works pretty well. Okay, so let's look at my to-do list because I forgot what I wanted to do. So let's go here, to do. Okay, so we've done triangle, we've done move into direction. Right, we want the right click to move. Okay, let's do that. Well, do right click to move, and then we will add bullets, I guess. So let's go here. Okay, cool. So now we're gonna do the bullets. So to do that, I'm gonna create a little struct as well for them. Little laser beam. So let's call this bullet. Let's call that bullet. That's an easy one. And we'll give it a, yeah, we'll give it a position. And we don't need a rotation. We don't want a velocity either. For now, it'll just be, actually, yeah, for now we'll just hold the position in here. And if there's anything else, we will, if there's anything else in there, we could add it to the struct. Hey, what's up, Seed Developer Prog? Thank you for joining. Thank you for joining the stream. I do these Monday to Friday, oh sorry, Monday to Thursday from 7 p.m. till 10 p.m. EST. So if you're down for these late night coding sessions, come by. They're kind of fun. It's been the most fun I've had in a while coding. So C developers have to stick together 100%. I actually like just recently started coding in C, and like I understand why people like doing it. I get it now. There's a few things that I wish, yeah, there's a few things that I wish C has some quality of life features, but otherwise it's really good. Like it's a really easy language to understand. It's honestly like you can have universities teach C rather than like Python or something. I learned Python and a functional programming language in university when I did that. But I feel like we should just start with C. Like it's a very simple, it's just simple language. It's so like there's really not much to it, you know? Like you could almost write a compiler for it is how like without losing your sanity is how simple the language is, but yeah. Anyways, time to add an array of bullets here. So instead of allocating a bunch of memory, I'm going to go ahead and just create like this big bullet array with 1,000 bullets in it. And I think that should be okay. And we will create a little counter for them too. So we'll size t. Nah, we'll do this. So this will be bullet count. And I guess what we'll do is whenever a bullet goes off screen, what should we do? I guess I want to recycle them, but I also don't want to like manage this too much. So I guess what I'll do is, so how about instead of having a count, I'll actually just have a little boolean in here called dead. And if it's dead, then we can reuse it. If it's not dead, then we can go at it. Then we still have to update it in the loop. So I think I actually have to add std bool for this. Std bool. Yeah, there we go. Perfect. So we'll do std bool for that. And we'll also create an initial, actually we'll put this below the player down here. Just keep things a little organized. And then here I will do init bullets t bullet. So this will be the position, which for now it will be 0. And dead will be true. Cool. Also, all my autocomplete is suddenly back, which is weird. Yeah, like, what happened? I don't know where my autocomplete came from. I don't know what fixed that. How about making an exploding balloon on the data screen? Just a thought. I could do that. I just don't want to. So, I guess the issue I'm trying to solve right now is I don't want to I don't want to allocate data right now. And so I guess what I could do is just have it so, well, I need a way to iterate through the bullets anyways. And so either like no matter what I do, I have to manage some type of array for them. And what I'm thinking is that like when you remove a bullet from that array, then you have to like shift all the arrays over. Like you have to shift all those elements over. And instead of having to write that type of logic, all I'm going to do is just iterate through the bullet, this array here. I'm just going to iterate through it every single frame. It's like 1,000. It's like literally nothing for like game for like C. So I'm just going to iterate through them 100, like every single frame. And if it's dead, then I don't draw it. And if it's not dead, then I will draw it. It's pretty much that simple. Because otherwise then I have to keep track of like a list size, and I have to like move things over, like push them over. Like I don't want to like work with that type of stuff. Kind of keep it simple, you know? Exactly. Keep it simple. And right now it's like definitely not going to affect your performance. If it ends up being a performance issue, it'll be super easy to fix, but for now, I like the idea of just having everything on the stack like that. And actually, I'll create a little define up here for max bullet count, and that'll be 1,000. Honestly, we could even put 10,000, but that seems like overkill. I think 1,000's okay. Honestly, 100 would be fine. I don't think there's gonna be more than 100 bullets on the screen at any point in time, so let's actually keep it at 100. Okay, so the next thing I want to do is create a bullet if I click. And I guess I also want to do a define up here for a bullet velocity. Bullet velocity. And that's going to be, let's do 1,000. Yeah, 1,000 pixels per second. I think that should be fine. Okay, cool. So here, yeah, we could just do this. Yeah, keep this entire area here for the input. So do I even need this here? This could move down here. I just want to organize this a little better. I won't have like the input at the very top, pretty much. That's kind of what I want to do. So I think that should be okay. And then if is mouse button pressed. For now, we're gonna make it so you have to like click the mouse button to actually shoot one bullet. But what I actually want to do is I want to put the bullet on like a timer, so it'll just consistently shoot as long as you hold the button down. But for this video, we're just gonna make it so you have to keep clicking the mouse button every time you want to fire a bullet. Just for now. Next stream, which will be tomorrow, we'll add some quality of life features once we have like the basic things set up. Okay, so to do that, we'll find the bullets. So I guess what I want to do is have a function that just gives me a bullet, and this should just take a bullet from our like this list here. And I'm actually gonna move this out here. No reason to have it in here because it'll be accessed by everything. So I think it'll be fine as a global variable there. And then here we'll spawn a bullet. It will just give me a bullet that I know is not in use, and that should be okay. So let's quickly write that function. So go. Let's do bullet spawn bullet. And we will return, oops, a bullet pointer. There we go. Cool. And then here what we will do is we'll iterate through our bullets list and just get the first free bullet that we find. So yeah, max bullet count, plus. And if there aren't any free bullets, then we literally just dip out of this function. So we just don't return anything. So for that case, I guess we'll return null. And here what we'll do is bullets I bullet E. Just do this instead, actually, like that. Same thing as doing array indexing, but I don't have to do the addressing operator on it. If bullet is dead, and we do bullet is false, and we return this bullet. So return There we go. Actually, we'll do it like this. So the main logic is in the main part of the loop. There you go. Okay. So if it's not dead, then we don't want it. We don't care about it. And then if it is dead, we will turn the dead switch off and we will return that. So that should be good enough to give us a bullet that we can use. And when we do that, we will set the position of the bullet. So position of the bullet, that will be set to the position of the player for now. So let's just do that. Perfect. And then for actually, yeah. And then for we actually have to move those bullets. So here we are moving the player. Here we're setting the velocity. So we're moving, yeah, here we're setting the position to, like, depending on the velocity and the acceleration that we've just added. So I guess we'll also do the bullet updating here. This is like the player update. We'll do the bullet update right under. So let's do that. So for that, we will have to iterate through all our bullets. So max bullet count. And we will take the... We also have a mouse direction here. So actually what I want to do is take this here. All this player direction. Just so I can reuse it later. Because we'll need it for the bullets. There we go. Okay. Then every bullet you get, let's get every single bullet here. Let's put it into like a little variable so we can work with it a little easier. Okay. And from here we will set the bullet's position to its own position plus the velocity that we have set up. So that will be, or the direction also, which we will need to put in here as well. So let's actually make a new vector here called velocity. This will be for the bullet velocity, and this will be scaled by, this will be scaled by the direction of the player. So this will be the direction, and this will be bullet velocity. Yeah, bullet velocity. All right, so that will be the velocity of our bullet. And then here we have to do the same thing, vector to scale velocity, but we also need to get frame time as well. There we go. So that should do it. Why am I getting this here? What's wrong? Oh, it's because I'm not closing all the brackets, I think. Yeah. Okay. So that should spawn a bullet and just have it move on the screen. But I actually haven't added a way to draw it, so I'm gonna do that. Draw. So here's something else we need to do. We actually need to give the bullet a, not a velocity, but a direction. So to direction. So in here, when we spawn that bullet, we want to set it to the direction, the same direction that the player is pointing in. So that will be player direction. There we go. There we go. Okay. All right. So instead of doing player direction here, we're actually going to do bullet direction, because these could be different. This could be different depending on when you shoot them, like what direction your player is in. So we have to store that. So there we go. And that's the normalized position, so that should be good. All right, so now we have to draw it. So I'm going to go ahead and do a draw bullets function down here. And we'll go ahead and write that. For now, it'll just be a pixel, I think. I'm just going to draw a pixel on the screen. I think that'll be fine. So draw, but it will be a line. I think it's cooler if it's like a little laser, you know? Okay. So now we have to actually do that loop again. So we're gonna get so many compilations errors. All right. Max bullet count. Plus, there we go. And from here we will skip anything that is dead. So if well, we need the actual bullet. So bullet T, bullets. There we go. If the bullet is dead, we will go ahead and skip that guy. But if it isn't, then we'll go ahead and draw them at the position that they have. So draw pixel. Nice, draw pixel V. Cool. And here we have the position, and the color will be red. Okay, so let's see how this works. We could finally try a build. That was a long session, long programming session. Built just fine. Thank goodness for error checking. All right. Nice segmentation fault. All right, so let's see what could have went wrong. It's definitely in the spawn. It's definitely in the spawn code. So let's see what I did wrong in the spawn code. Where is it? All right, spawn bullet. Where did I go wrong? I guess maybe. Okay, one sec. What am I doing wrong here? Oh, one thing I do need to do is I have to check if... Where's my spawn? Here. What? Oh, right here. Here's the spawn. Whoops. I was just getting confused. All right. So actually, we have to check if this actually exists, because that function could potentially return null. So I want to try actually building with that, and maybe does it crash? Okay. So the reason it doesn't work, it's because for some reason it can't find a live bullet. So the reason for that is because I actually never initialized the bullets array. So I'm going to do that real quick. So every bullet should start off dead. And right now I think they're all starting off alive because the variable is dead, not alive. So it means when I'm iterating through them, the initialized value is alive, and therefore it never finds a bullet. So let's quickly fix that here. I guess I'll make a new init bullets method here. And I'll write it up here. Init bullet. I guess, do we even need this? I don't think we need this, because that's spawn bullet kind of does it already. So this will convert into spawn bullets. Or sorry, init bullets. And we will delete this parameter here. And then we'll just iterate through all of our bullets and make sure they begin off dead. So let's do that. Max bullet. Okay. Bullets I dot dead. And we'll also make sure to set their, actually I don't want to set anything else. We could leave everything else at 0. Yeah. Everything else could be set to 0. That's fine. Okay. So I think that should do it. Let's see if that works. Alright, so we do get the bullet. It's like a very, you probably can't tell from the video because it's literally 1 pixel. So I'll make it a line instead. We'll make it a little laser instead. Language from the start. Oh, I see. It's because I understand why I'm getting that error. I get it now. Because Neovim is dumb and assumes I should be opening it from here. Yeah, so that's why I wasn't getting autocomplete. I have to open it from my actual project folder. Okay. So now let's do a better draw for the bullets. So, how much time have we got? Okay, so that's 1 hour and 30. I think we could still get to the goal that I want to do, which has the asteroids and like we can break them. So let's do let's do, instead of making it a pixel, we will draw a line. Draw line V. All right, so the start position will be the bullet position, and then the end position will be an addition to this. Or sorry, yeah, in addition to this of bullet dot position. So we're going to add something to bullet dot position, and it's going to be the direction. Well, let's actually we can one line it, fine. So this here, that's going to be that. Let's scale. So that's going to scale on the bullet direction. Bullet position. And we're going to actually scale it backwards by, let's say, we want to make it 10 pixels. We want to make the line like 10 pixels big, I think. I think that should do it. And then I can delete this guy. And then we can add the color here. Okay. Let's see how this works. Start builds. Alright. Alright, so we got a little laser shooting. It's kind of neat. But if I shoot 100 of them, it'll eventually stop. So let me get all the way to 100 so I can verify that. It's kind of neat. You can shoot. Yeah, so once we get to 100, we run out of bullets. And that's because we don't reset them. So I guess when the bullets leave the screen is when we can reset it. And for now, we'll also, like, eventually, like, maybe tomorrow, when I work on this again, the bullet will come out from the tip of the spaceship, but for now, it's fine that they come out from the middle. I think that's okay. Okay, so let's get some bullets back into the game. So let's do that. So I guess what I have to do is, again, iterate through all the bullets. I should make like a callback function or something that does it for me. But here we have the position. So after we have the position, we can actually check how far outside the window is. So if bullet position dot x is greater than or is less than, let's say, -10. Let's do negative 20. So it's just outside of the screen. That's like at some point outside of the screen on the left side. But then bullet dot dead. Then bullet is dead. Set that back to dead. And now it should be able to be used again. We also need an or here. So or bullet dot position dot x is greater than, and let's do get and screen get window. What is it? Get screen width. How do I get the screen width? It's just get screen width. I don't know why it's not finding that. Oh, there we go. So if that's greater than get screen width plus 20, then it's also going to be dead. We also need, so, or, and now we do the y's. So if it's less than -20, so if it's somewhere over the top of the window, and we want to delete it as well. And if it's too far off the bottom, we also want to get it again. And for now, we'll also do a little printf here. So bullet deleted, bullet died, and we'll put in the index, the dead index of that bullet. So that'll be bullet I. Okay, so now we can check. Why is this failing? Oh, think this has to be LU with that. Yeah, okay. There we go. There we go. Okay, sorry, just checking the time here. Also, either the music's not playing or it's really quiet. Let's change it up. Okay, there we go. Start something else there. Okay. Okay. Right. So let's hit compile. Cool, and now let's see. So, cool, bullet died. Okay, yeah, I see. That's cool. So it just keeps getting the it now it reuses the bullets, which is kind of neat. It's interesting. It's cool. That's neat. I think that does it for making the bullets reusable. I think that does it. Yeah, if it's less than -20, we're... But what I'm having trouble with is why... Ah. Here we're adding... Here we're not skipping the dead bullets. We actually have to skip the dead bullets. And all the bullets are inside the screen right now, so that's why they're not... I get it. So we actually have to do a check here to see if the bullet is actually alive. So if it's dead, then we want to skip it as well. We don't care about dead bullets. There we go. So now it should... Actually, 1 second. It should print... I want to do this print F1 thing again. Bullet died. And that will be... And this will be... Okay, so we'll go back to our build folder. Main build, okay. Alright, there we go. Alright, so yeah, it only shows... Cool. That's really neat. Okay, so now we are re-getting our bullets, which is nice. We technically have infinite bullets. Alright. Alright, so let's check our to-do again. So we did left click shoots, we did all these. That's done, that's done, that's done. Okay, so now let's create the small asteroid, which have about 1 hour and 30, so there's definitely still time to implement this. So now we have to create the small asteroid that when you hit it with the bullet it dies, and the big asteroid that when you hit it it turns to small for small asteroids. So let's do that. Okay, so this one will be a little bit more complicated, I think. Because actually we'll do the same exact trick we did with the bullets to deal with the asteroids. We'll have a limited number of asteroids on the screen, and both asteroids will be represented by one struct. So let's go here. This is the bullets, and now let's define the structure for... I need to make this a little smaller. Oh my god, I've just been looking at giant code for a long time. Okay, so now I will create a new struct here for asteroids. Asteroid. There we go. Underscore 2. Okay. So asteroid will have a couple of properties here. It'll have a position. It will have a velocity. We want them coming in. We want them to have differing velocities. Not unlike a bullet, it just will always have the same velocity. And we'll also have an extra value here called big. So big just means, or let's make it a number. So pieces. We'll call this pieces. So the big asteroids will be 4 pieces for now, and the small asteroids will be 1 piece. Nah, we'll make it big. Is big. Okay, there we go. So is big just makes it so just tells us whether the asteroid's like a 4-piece asteroid or just like a single one. So yeah. And the music's too loud again, so I have to turn it down. Okay. Okay. So let's write a function called spawn. Well, now we need an asteroids array. I think 100's fine. I think having 100 asteroids on the screen is a lot, but just to be safe, we'll do 255, 256. So a byte's length worth of asteroids. I think that should be fine. And instead of doing a dead field, we'll do an alive field, just to make our code more confusing and inconsistent. But eventually we'll change the bullet to change the bullet into an alive field as well. So I'm gonna just quickly leave it to do for that. Do change dead to alive. There we go. So for now that should be okay. All right. So what do we need to do? So I guess the first thing I want to do is, so I want to spawn these. I want to spawn just one of them. So spawn asteroid, and I think what we'll do is we'll give it a position to spawn at. So yeah, we'll give it an X and Y spawn at, and we'll give it a size. So is big. So now we will get a free asteroid from somewhere in our array. So let's do size t, I = 0, I less than. Let's define here max asteroids. Asteroid count 256. Max asteroid count. There we go. Max asteroid count. Okay. We'll also do a quick init method for them, so. And that's also just to iterate through them and make sure that the values have been initialized properly. So here we can do, let's actually just get the asteroid. Asteroid is equal to asteroids I. Okay. All right, so then after that we can just set it up. So live is equal to live false, asteroid big is equal to false, asteroid position, we'll make that equal to 0. And we'll also make the velocity that as well. Okay. So that should initialize them good enough. And we'll do init. Perfect. And then we'll also, yeah, so now we'll create a spawn asteroid method here, or sorry, a function here. So let's do that. Asteroid _t asteroid, that's equal to asteroids plus I. Okay. If it's already alive, then we will skip it. Otherwise, we will go ahead, and this is the thing we'll be using now. So asteroid T, asteroid, null, and we'll make this use that. And if we get past here, we break. Okay, and we'll put this in brackets just because it looks clear to me. That's fine. Okay. So if we find an asteroid, we'll break, and if we don't, we'll get down here. And if asteroid is equal to null, then we will also just return that immediately, because we can't do anything. Okay. But if it isn't, then what we're going to do for now, it's just going to spawn asteroids from the top of the screen moving down. But eventually we'll make it random. So for now, just so I can make sure to get through the stream, I will make it so it spawns from the top. Asteroid is never going to be null. How? That's true. Actually, yeah, you're right. You are completely right. You are completely right. Thank you for pointing that out. So I guess what I'll have to do is, it's a simple way of doing it. I won't be too stingy about it. I'll do that. There we go. Thank you. It's a good catch. Okay. That was confusing me. Okay. Perfect. Thank you for pointing that out. That was a really nice catch. Saved me some trouble there. All right. So, what's next? What did I want to do? Oh yeah, spawn at the top of the screen. So, for now, it'll be asteroid position dot y is equal to get, or I guess it'll be, let's do negative 50, I guess. So it's like above the screen a little bit. And for now, it'll come from the middle of the middle of the screen on the X. So screen width, and we'll divide it by 2. That should be fine. And we also have to set it to a live. So asteroid live through. And I think we're almost there. And we also need to set the velocity of it, which for now will just be down. So let's set the velocity. Y is equal to, let's make it a little slow. Let's make it 100. So that should be going down at 100 pixels per second. And is big is equal to, now we're going to spawn small ones always. We already have the parameters, so we'll do it like that. Okay, so I think that should be it. Just make sure, yeah, we got all the values we want. Okay. There we go. And now we have to do the updates on that. So we have to do the same thing we did with the bullets. We have to do with the asteroids. So let's quickly do that. Eventually I'll put these in an update function just to keep it a little cleaner, but for now I'm just gonna inline everything. And asteroid count plus asteroid T. Asteroid is equal to, okay. Alrighty. And from here we only do this if asteroid is alive, so if you're not alive, we're gonna go ahead and skip you. Cool. And if we get to this point, we can now add the what was I going to say? We can now move it. So yeah, let's do that. So this will have, I guess, the velocity. Yeah, the velocity should hold a direction. So all we need to do is augment the position. So let's do that. So this is going to be vector2.add, and we're going to add it to the position of our asteroid once again. And here we will scale our velocity by our get terrain time. There we go. So that should change the position appropriately, I think. It's done. And for now, what we'll do is we'll copy this down here, but we will have like a more general way of checking if objects have left the screen. But for now, I think this will be okay. Asteroid. Okay, I think it's good. So, and then here, live is equal to false. Okay. So that's good. Now we've updated all this is the asteroid update, and this is the bullet update, and this is the up here player update. Yeah. Okay. Have that nice and labeled. And then down here in our draw, we will draw our asteroids. Draw asteroids. Cool. So we'll go ahead and implement this function now, the draw asteroids function. Just implement it down here. Draw asteroids. And once again, we have to go through them all. So here we have to get the asteroid. So let's equal to asteroids plus I. If asteroid is alive, if it's not alive, we don't care about it, so we skip it. There we go. Oops. Delete that. And here we can go ahead and draw it. So for now, it's just going to be a rectangle. And there's two types. So if it's if the asteroid is small, so if it's well, we'll start with the big just because that's the positive one, and then we'll do the small one. Okay. So draw a rectangle. So big will be, let's say that the big will be, for now it'll be, let's add some dimensions to this. We have to add dimensions here. So let's do bounds. For now, I'll do the bounds. I'll do the bounds when we'll do collision checking in a second, but for now I'll refrain from adding stuff I don't know if I need yet, so I'll do this first. So this will be asteroid position dot x, and we'll minus, I think we'll make, let's see, let's set the defines up here at least to get our asteroids the right side. So asteroid big, let's do the width height for the asteroid big is going to be, let's do 32. So it's going to be kind of big. And then for a small asteroid small, width and height, that's going to be, let's do a fourth of that. So that's going to be 8. Okay. So the little ones will be 8 and the big ones will be 32, which makes sense to me, since they'll break up into 4 parts. So max, asteroid big, width and height, divided by 2. Let's put these all in, let's all line them up like that. So asteroid position dot y minus asteroid big h, and then we need the width and height. So that will be asteroid big with height, asteroid big height, and the color will be also red. I think there's also a way to do rectangle lines. Yeah, that's what I want. I want the lines, so I want it to be see-through. And now that I see this, we can actually set the size outside of this loop and then just reuse this to draw. So we'll do that. So asteroid size is going to be equal to asteroid small, so that's going to be a default. And then with big, we will set asteroid size equal to the big width and height, and then we'll just take this guy and update it here. Okay, and now we have to switch all of these. So asteroid big height, we will switch it out with asteroid size. There we go. Okay. So that should draw the asteroids just fine, I think. If they appear. And now all that's set to do is that we need to spawn them. So for now, I'm going to make them spawn on space whenever I press space. And I forget how to check that input in... raylib, so I'm going to quickly do that. If is key... Oh, cool. So it's just right here. It's the good thing about having autocomplete. And then I think we'll do button key... There we go. Key space. Perfect. Nice. I love how you can just sort of guess what you need. And then we'll do spawn asteroid. And here we're setting a position, which I don't think we actually need for now, because I think I've made it so it always spawns. Yeah, so space will be a big asteroid, and then we'll do comma for a small one. See how that looks. Okay, so I actually don't think we need to put anything in there yet, because right now it's just hard-coded to be like the top middle of the screen that's going to spawn. And I guess I'll go quickly check. Yeah, so everything's hard-coded in right now. We don't even use X and Y right now, and I think we'll probably get a compiler warning for it. So, or maybe not, because I don't know if I have warnings turned on, but whatever. Okay, so build. Okay, cool. And now I can try it out. So space. All right, nothing's coming in. All right, so what went wrong? Okay, so the first thing I want to check is I want to make sure that I am spawning an asteroid. So right here, I'm going to do a print spawning asteroid. Okay, and in spawn asteroid, let's check what this does again. This will go through the asteroids, and if it's alive, we continue, and if it's not alive, we return this guy, and if that's null, we return, and then we set it to alive, we set the position, we set the velocity. That should be fine. That's the down velocity. Cool. Oh, actually, yeah, we do draw it, so we are drawing them. So where... Oh, it's because of this. Because it starts outside. So let's actually comment this out for now, and we'll figure out a better solution for this later. Because it actually has to come into the screen before we decide that it's not supposed to be in it. Oops. Let me try it again. So comment this out. Why does that not work? That's really annoying. Weird that it's not commenting out. Okay. So I guess I'll just do manually this guy. Okay. Okay, so that should be better. Ooh. Okay, space. Hey, we have a little cube coming. Hey. Nice. It's moving kind of fast. Another one. Cool. Hey, there we go. We have asteroid spawning. And if I press comma, hey, we have a little asteroid spawning. Cool. Boom, 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 boom. Neat. Alright, so let's do some collision checking to make sure that we can properly detect these things. And I'm going to just quickly go to the bathroom. I'll be right back. And we'll implement some collision detection. Be right back. Alrighty, okay, cool. Let's keep going with this. So the next thing I want to do is I want to add collision detection. So let's do that real quick. Collision detection will basically be if a bullet touches an asteroid, we're going to make it dead. And depending on whether the asteroid is big or small, we will adjust like what we do with that. So if a big asteroid dies, then we'll spawn 4 little ones, and if a little one dies, it just dies. So cool. So let's do that. The first thing I want to do is check for collisions. So here, this will happen in, so we'll let both the bullet and the asteroid update. Actually, I'm just trying to figure out when do I want the collision to happen. I think I actually want it to happen between the bullet and the asteroid update, and the reason for that is because there could be in rare situations, I guess, where they'll both update at the same time, and like the bullet could be here and the asteroid could be here, and when they both update they'll be like that, so it would never touch, and I kind of want to avoid that. So that could already happen if like the bullet's moving too quickly and it moves past the asteroid. So I guess to minimize the chance of that happening, I will do it in here, so only the bullet updates before the asteroid updates, and we'll check if any of the bullets hit any of the asteroids. So yeah, so I guess we'll do that in this bullet loop here. Yeah, and here we'll do another check. So if the bullet's dead, continue, right? But if it's not dead, then we wanna actually check if it collides with any of the asteroids. So this will be kind of a bigger operation now, because we will be doing, I think it'll be 100 times 200 calculations here, because we have to check if any of the bullets are touching any of the asteroids. But at the same time, I think it'll be okay. Yeah, I think it'll be fine for now. I'll make sure to, if this ends up being slow, because this will be like a 100 times 256 calculation. If this ends up being slow, then I will have to write a dynamic array for this type of stuff, and I'll probably use like STB or some shit. But for now, I'm just going to be okay with the performance hit for doing the collision checking. Okay, so now we have to go through all the asteroids. So let's do a J here. Max asteroid count. Plus, and now we need the asteroid. And that's equal to asteroids. All right. So now we can check if the bullet hits the asteroid. And this is actually isn't too bad, because the asteroid has a position. Well, okay, so the asteroid has a position and a size in the rectangle. So you just have to check if the bullet's inside that rectangle, which is a very easy to do check. But now I want to write a new function up here. Well, here we have draw asteroids. I kind of want to do get asteroid bounds. I kind of want to do that, and I want to this will basically return the rectangle for the asteroid, which we'll make sure to change this when we'll have to refactor this when we do more complicated asteroids, but for now I think it'll be okay. So here let's actually put in the asteroid, and the asteroid here, and now we can do this. So what we did down here, basically return a rectangle. There you go. So to return this rectangle, we'll do x is equal to asteroid position dot x minus asteroid size divided by 2. We'll put this up there as well. So this has to be up here. Okay. Asteroid size divided by 2. Then we do y, which is asteroid position dot y minus asteroid size divided by 2. And then we do width, which is equal to asteroid size, and height. Oops. That's equal to asteroid size. Cool. And then we will return the actual asteroid bound here. So asteroid rectangle, and that will be get asteroid bounds, and here we will put in our asteroid. Then when we do this, we can do draw rectangle lines, or we can do draw rectangle. Maybe there is, yeah, right here. We'll use this guy. So this will draw our rectangle and what we want. So asteroid rect, and it'll be just 1 pixel width, and there we go. So that should do it. That should run exactly how it did before, I hope. So let's do a quick check on that, and let's check asteroids, press space. Cool, so now we have this box coming at us, and if we press comma, we have the little asteroids. Okay, cool. And all right, so now we can do the check here to see if the bullet is inside the asteroid. So let's get the asteroid rectangle again here. Or what we actually have to do is check if the asteroid is even alive. So if asteroid is alive, if it's not alive, we will continue. Otherwise, we will get its bounding box. So get the rectangle, asteroid rectangle, get asteroid bounds. Here we go into asteroid. There we go. All right, and then all we have to do is check if the point of our bullet, the position is inside this rectangle. So let's do that. So I think that is collision. There we go. Check collision point. There we go. That's what I want. So the point will be our bullet position, and the rectangle will just be our asteroid rect. There we go. And if there's no collision, then we will continue. We don't care about it. But if there is a collision, then we do some logic in here to figure this out. So for now, all I'm going to do is erase it just completely. So all we're going to do is take this asteroid and set the alive to false. No matter what asteroid comes, if it gets hit by a bullet, we're just going to make it false. So let's do that. So the cool thing about asteroids, eventually, like, the asteroids need to, like, wrap around the screen, and The player does too. I will do it on the next video, screen wrapping and all that kind of stuff. But for now, we can just leave it like this. Okay, so let's see if this collision detection works. Alright, so here we go. Nice. So it doesn't catch this one, which is interesting. Huh. I wonder why it catches this one. Huh. That's so interesting that it does that. I wonder why. Okay, let's do a little guy. Just... No, it's not like this. Okay, so it does. That's weird. I guess what I could check is for... Actually, I'm not sure why it's happening. I should also probably delete the bullet if it hits the asteroid. So I'm gonna do that as well while I think about why I'm getting that issue. So let's go here and let's make sure that if we do collide, then the bullet also dies too. Bullet is dead. And we break. We break out of this loop. We're done. We found a collision. So let's run this again just to make sure that works. Cool. Why doesn't that work? It's weird. Oh, it works from the bottom? What? So that works. That's so weird. Why does that work like that? Second. I need to get this guy. This need to get the guy to stop moving. So this kind of works like that. It's just, why does it go through the other one? This is like really weirding me out. Huh. 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 Right, well, let's see what could be going on. So I guess the other thing I want to do before I actually do that, I want to, just so I can finish what we're doing in this video, since we're nearing almost 10-ish, so, and I need to get off after that. So let's quickly spawn four asteroids when one dies here. So if the asteroid that was killed is big, then we want to spawn 4 asteroids around it. So let's do that real quickly. And what we'll do is spawn asteroid. And here's where we actually need to like use the position and size of the asteroid. So let's go here and actually fix that real quick. So here I set it to have the screen width, so we'll set this to X, we'll set this to Y, and then whenever I call spawn asteroids right here, we will do get screen width divided by 2, -50, and the same thing down here. Width divided by 2, -50. So that's just off screen. All right, and now here, Where did I not close it? Oh, here. Okay, so here now we will do spawn asteroid. This will be asteroid position.x, asteroid position.y, and it's going to be a small guy. Okay. And we're actually going to do this 4 times. And we're going to set the velocity to random directions. So I don't know if raylib has like a random velocity. So what I'll do is, I know that he might have like a random, set random seed, get random value. Okay. So we'll get a random value here. Is there any other random sequence? We'll do random value, and I don't care what the seed is for now. The minimum will be 0 to 100. And we'll do this. Actually, here's an even easier thing to do. We'll actually just take a vector like this. We'll call it up. For now, we'll call it velocity. Why not? And here we will create a vector 2 where it'll be pointing upwards. So it'll be something like that. Good. And then we could do a clever little trick with vector rotation. So we'll do velocity is equal to vector2 dot rotate. So we'll rotate it, let's say a random amount between 0 and 100. So let's do get value. Let's do between 0 and 100. And let's divide that by 100. Like this. And then let's multiply all this by tau. There you go. So what this will do, what this will do is actually pi times 2, because I don't have tau anymore. Okay, there you go. So what this will do is actually just rotate the vector around and point in a random direction, which is kind of what we want. And then we also want to scale this up by whatever the velocity of the big asteroid was. So right over here, we're going to get the velocity of the magnitude of the velocity. And this is going to be equal to vector to length. And this will be on asteroid velocity. So whatever the velocity of the asteroid is, we will take that and we'll just use it for our velocity for our asteroid that we spawn in. So we'll do this, and this will be vector to add scale. This will be velocity by velocity. We also need a way to actually get the asteroid that was returned here with the spawn. So let's quickly actually return an asteroid here. There we go. Instead of returning nothing, we'll return null. And here we'll return the asteroid that we got. There we go. Okay, so now we can go back down here and we can take the asteroid T, small asteroid, child asteroid, and we'll put that up here actually because it's possible that, you know, you won't get one. So if not, so if child asteroid is null, we're actually going to break out of this loop because there's nothing really we can do. There's no more asteroids you can get, so we'll break out of the loop. And here we will take the child asteroid and we will set the velocity equal to our the velocity we just calculated. Okay, so the big asteroid should turn into little asteroids and they should fly in random directions. So let's quickly check that. Build main asteroids. Okay, so space. Cool. So that kind of works, but it's not doing what I thought. Like it's so weird that that doesn't work. Huh. It's just it's just strange is all. I'm not sure what I'm doing wrong there with the collision checking, but I guess we can now look at it now that I've made sure that asteroids explode. So let's check the collision. Yeah. So huh. Let me think. So I'm wondering why it's not detecting that the asteroid hasn't been hit after the first one. Oh, oh, asteroids.I, asteroids.A. That's why you have better naming schemes, guys. All right, so that should be cool now. Yay! And we can destroy. Oh, it's interesting that it's going in a random direction. That's cool. That's really neat. But why is it going in a random direction? That's weird. Oh, you know what it is? It's because oh, it's reusing. Oh, that's so cool. Because of the pool, the pool of asteroids. The pool, it's getting the it's not changing the velocity. We're not. It's because we don't set the velocity anywhere. So, all right. So let's quick that quick asteroids. So we actually do need to like here's where it spawns, and here we are returning. Okay, so I guess what we should do is set the velocity not here at spawn, or not here at spawn asteroid, but I guess we could set it here. Actually, what I want is hmm. What I want to do is actually let's see, what should I do here? The reason it's moving down is because we set the velocity to down, but like the reason it's moving every other direction is because we actually don't set the x, so it's reusing the x from a previous asteroid. Okay, so let me think. I guess what do I want? How do I want to do this? I guess I actually don't want to set a velocity here. I actually do not want to set a velocity here. And in fact, I don't even really want to set the no, setting the position here is fine, just to have like a just to like make sure something's set up properly. So all right, so I think that's okay. But instead of making the spawn always above the screen, we're actually gonna pick a random location outside of the screen. And what's cool about, and we're also gonna make sure. I mean, we'll figure out like how we do levels after. But for now, what we'll do is we will take a random position on the screen and then move it in the direction that's towards the screen. So let's pick, I guess let's first pick the direction we want to come from, I guess. Yeah, I think that's good. We pick a direction, and then from that direction we take the middle of the screen, and in the opposite direction we move it to like the opposite way of like of the screen. So the asteroid will be, so we'll set the velocity like, let's say like diagonally downwards and diagonal. So we'll set the asteroid to be off screen on the top left, if that makes sense. So I think once I implement it, it'll make more sense. So space now will spawn either or of these. And to do this, we will use random get random value, get random value. There you go. So big is going to be is big. Get random value, and here we'll do 0 and 1. I hope that's inclusive. But if it isn't, whatever. But if it is, it's good because then we can just use these as the, and we'll also just convert it into a Boolean just so it's clear what we're doing. It is already clear, like the type's written out. So here we're picking one or the other, and instead of is true here, we put is big. All right. So now the other thing we need to do is we have to take this asteroid. And if the asteroid doesn't equal null, then we can do stuff here. Okay. So here, I guess we have to do a bunch of calculations. This is the reason why it kind of sucks putting in the position in here. It's because we have to do calculations before we even spawn it. And then it could be the case that like there is no asteroid, so we do the position calculations for a reason, but it's not that big a deal. Okay, so let's first pick a direction. So random direction. So this random direction is going to be some vector that is pointing up like this. And then what we're going to do is vector 2. Then what we're going to do is actually multiply this, or actually rotate this by some random number. Get random value between 1 and 100. 0, 100, and then we're going to divide that by 100 like that. And here we'll put pi times 2. There you go. So that will give us a random direction, which is good, and it'll be normalized. And then what was we going to do here? Right, so now I want to set this off screen somewhere in the direction opposite of the random direction. So to do that, I will set this to, we will take, I got it. So is there a way to get the sign? Is there sign? Okay, so I think I do need math here. I think I do need math because I need to check the sign of the vector here. It goes so deep. Fine. Sorry, I was just looking at something else in my head. I keep forgetting that like I have to like talk more and be more like checking the stream, like be more talk more about what I'm doing for the YouTube video I want to put up after. I keep forgetting to do that. I'm still getting used to all this. Okay, here. So if it's not null, or actually don't check that right now. Right, so we got a random direction here. And I guess here we want to go sign F. Sign. Where's the sign, like? Sign C++. Okay, sign F. Where's sign? I thought there was sign F. I really thought there was a sign F and C. Like, wasn't there a sign F and C? I swear to God, there's a sign. Okay, so apparently there's no. I thought there was. I really thought, like, I thought I was using it. Okay, well, we can just do it inline for now. So I don't want to create like a function for it, but we will vector start position. This will be get screen width plus, let's do 10. Yeah, let's do plus 50. So just it's off screen. Or I guess what we could also do is get the asteroid size. But I don't want to do that actually, because yeah, no, we'll just do plus 50. We should probably not put the position in here, just whether or not it's big or small. But whatever. For now, it's okay. So vector 2, and we will do vector 2 signs. And here we will do random direction dot x greater than 0, then 1, otherwise -1. So if it's equal to 0 as well, we'll make it 0. We'll make it 1, I mean. And for the other one, random direction dot y. If it's greater than or equal to 0, then we do 1, otherwise we do negative. Okay. So that will be good. Here we will multiply this by science.x. And then we'll do get screen height plus 50 divided by 2. Oops. I guess this will be like the relative, sorry, the relative from the middle of the screen. I'll just call this relative. Plus 50 times science.y. Okay. And this actually needs to be that. That. Which one's closest? This is that. Are you happy now, C? Okay, good. Okay. So that should be good. That should be the direction I want to get out at. Some different lines just so it's easier to see. There we go. And then this relative vector we will add to the middle of the screen. So screen middle actually looks like this. It gets screen width divided by 2, get screen height. There's probably a better way of doing this, but my brain's pretty fried. So this is gonna be the way to do it for now. And then here we'll do another vector actually. Vector 2 spawn position, and this is going to be vector 2 add middle with oh, okay. What did I do here? 0. Okay. And here spawn asteroid, we do spawn position.x, spawn position.y. Okay. That's looking good. Is big. Okay, so now that should be fine. If the asteroid doesn't equal null, then we can set its velocity. And that's going to be equal to vector to scale. That's going to be random direction multiplied by, let's do 100 for now. That's okay. We'll put in the same thing we put in before. So that should be good. This should spawn randomly. It should spawn either big or small asteroids somewhere off screen. And it should launch them in. I think that should be good to go. So let's quickly build this. That builds, and then if I press space, I should have asteroid coming in from somewhere. Maybe I'll spawn a bunch to see. Hey, you know what it might be? It might be actually because I think I know what I did wrong. So it might be because I did not specify like the direction I put in for spawn. The direction I put in here. Where is it? This relative direction here. This should actually be the opposite. So this should be like that. I think that should help. Okay, cool. Hey, we have asteroid. This is neat. Yeah, we have asteroid sort of. We have to press space to spawn in the asteroids, but we got asteroids sort of. I can barely hit that, so I'm gonna have to make them smaller or bigger, I mean. So okay, let's actually fix that real quick. So back in here, we will change the asteroid parameters here. So let's, so a big asteroid will be 2 and a small one will be 16. Yeah. Cool. Make asteroids. Alright, so now we have slightly bigger ones, and yeah, that's cool. So right now they don't wrap around the screen. And so when they leave the screen, they leave forever, but the idea is that they would wrap around the screen. But for now, they literally just come in and then they leave because they there's no logic for them to come back. So I think that's fine for now. We'll implement screen wrapping in the next session. We'll implement a bunch of quality of life stuff to this game. Okay, so that's pretty good to go. Now I want to check what else I had in my to-do because I totally blanking on that right now. So 2 types, big, small. Touching any asteroid is game over, and then we'll do scorekeeping, and then we're done. I think we could do that in 30 minutes. I think we can do that in 30 minutes. So let's do that. So the first thing I want to do is check collision against the player. So I guess I want to do that before any asteroid update or after any asteroid update. I guess we could check on the asteroid update. While we're iterating through the asteroids, we'll check if it's touching the player, and if it is, we'll exit the game. We'll literally just close the game. Also, this needs better logic, so I'm just gonna go ahead and delete it. I don't want to have it there anymore. Okay, so let's see how we're gonna do this. I guess all I have to do is get the bounds for it. So let's do rectangle bounds asteroid bounds, and that's going to be equal to get asteroid bounds, and that's going to be equal to that. Okay, so and then all we have to do is check if the player's inside of these bounds. So in the next video we'll probably make these quality of life updates, but there is a cool, so in raylib there's a bunch of check collisions that we can use. So right here we have for example, a point triangle. And so what we could do, or where is it? Is there a triangle collision? I thought there's point poly, lines, rex. Okay, I thought there was a better check. Point poly. Collision lines. Okay, so that's probably what I need. This is what I want, yeah. So maybe in the next video, we'll use this to check if, the triangle is overlapping the the square. We'll use a bunch of these check lines to see if any of the edges of the triangle are intersecting with any edges of the square, and if they are, then we know there's a collision there. But for now, we're gonna just check if the triangle is inside one of these, or at least close enough. I think we'll make it close enough. I think close enough will be fine. So I think if it's yeah. Or is there a circle rec? Yeah, so here it is. I think we'll use this one. Check collision circle rec, and the point will be very small. It'll be like 5. Like the radius will be like 5. So it'll be a very small collision area to die from, just to make it easy. Okay, so let's do that. That's all I have to do. So if check collision, where is it? Circle rect. So here we will put in our player position. The radius will be 5. And this will be the bounds. I think that's it. And if this happens, how do I close window? Close window. Exit window? Is there a way to just like nuke out of the of this? Nuke out of the program if you get touched. So it must be somewhere here, hidden full screen, state maximized. How do I force close the window? How do I close the window? Let's see. It's cool. It has some file management stuff. It's neat. That's nice. How do I'm gonna just try close window. Close window. If application should close, escape key. Close and unload OpenGL context. Does this make if window should close true? I guess I could just break out of the... It's just that we're in a loop in here. Okay. Let's actually quickly create a game over. False. And here, game over equal to true. Keep it simple. And here, if game over, let's make it so we just get out of the loop. The game closes. We'll make the player explode or something otherwise. So let's make something kill me. Interesting. Nice. Alright, so that seems to work just fine. So we did player dies when we did that to do item. Yeah, so we did touching any asteroid game is over. That's good. And now finally, we will add a score. So let's do that as well. So to keep track of the score, for now, it's just going to be a variable inside our loop, which will be right here. We'll call it score, and it's at 0 for now. Cool. Cool. And I also want to like randomize like the bullets. I don't want to make it so it's space. So what I'm gonna do here instead is I'm going to add a makeshift timer here. So it's going to be timer. That's going to be asteroid spawn seconds. And that's going to be set to some default value I set up here. So define asteroid spawn second. That's going to be equal to every 0.5 seconds I want an asteroid to spawn. So let's do that real quick here. It's an asteroid spawn seconds. Okay, cool. And down here, every single frame, we will go ahead and asteroid spawn sec. We will minus the get frame time from that. And when asteroid spawn sec is less than 0, we will spawn in an asteroid. So spawn sec, that's equal to get frame time. Oops. Asteroid spawn sec. So we'll reset it, and we'll also minus, because this will be negative at this point. So it'll be like, for example, like it'll be at like maybe 0.01 seconds, and then the frame time will move it like to a negative number. And if it's a negative number, then we actually want to compensate that for the on the next frame. So we can just put this here like that. And what this will do is it'll minus we'll add it. And what this will do is that whatever amount we went over by, it'll be compensated into the next round. So yeah, so this will make it so every frame, at least, like, let's say for example, like we get a big lag spike, and 10 seconds pass between the lag spike and the asteroid spawning. Well, every frame after those 10 seconds, what will happen is it'll always be like -0 for a while, because whenever we add spawn after spawn sec, it'll be like a very negative number. And so it'll be negative every single time it goes through this loop. It'll be like another negative number. So every time it goes through, every frame, it'll spawn something. So what we should do, if you want this, for example, if 10 seconds pass, right, we want like 20 asteroids to spawn at the same time, not like once per frame. But we'd have to create a while loop for that, and I think for now this is fine, and it's also something that will only handle like an edge case, so who cares? An edge case where you're not getting 60 FPS on this asteroid game, so it's really not that much. So I think they should add a timer now to spawn asteroids. And just to make sure that's working, I'm gonna go ahead and build again. Okay, so now I just have to wait a little bit. Okay, cool. So now we have asteroid spawning no matter what. And we have our system to destroy them. Cool. And we can go around. None of them has hit us, which is funny. Okay, there we go. We weren't even trying to get hit, but we kept getting hit. We weren't getting hit. Okay, so now finally let's add in our score. So every time we destroy an asteroid, which is, where does that happen? Here. This is when an asteroid is destroyed. If the asteroid is small, we'll add 1 point. Actually, we'll add points for whatever asteroid is. We'll just add more. Yeah, we'll just add 1 point per asteroid. So every asteroid you hit, you'll get 1 point. Just for now, we'll make the score system more complicated, but for now, I think this will be good. So let's do if asteroid. Well, actually, all we have to do here is score ++. I think that's it. Yeah, this is like, here we're already checking there's a collision with an asteroid, so that's good. And then here we will finally draw text for that. So draw text, and then we'll do format text, format. Nice. And here we'll do it score. Score will be there we go. Score will be just an integer. We'll put in the score. And then we just put in 0, 0, because I want this to be at the top right corner. We'll make it pretty big. Let's make it 64 in size. And we'll make the color You guessed it, red. Alright, so I think that should do it. I think that about finishes this video if everything works as I expect. Let's build. Okay, so now we have score 0. Okay, cool. Nice. Score 1, 2, 3, 7. Nice. Whoa. This is cool. Okay. And that's our little asteroid game for now. That's cool. I can't believe we did it. That wasn't too bad. And in under 3 hours, we did it. That was kind of fun. That was kind of neat. Let me check the to-do list one more time. So, yeah, we create the player. We make it move in the direction. Asteroids to type. 1 breaks into 4. Touching an asteroid is game over. And we keep the track of the score of how many asteroids we've destroyed. Cool. Really cool. Really neat. Let's play it one more time for good measure. See how far, see what's the biggest score we can get. Maybe. I guess it's, I mean, it's not that hard, so maybe it can go on for a while, but let's see. Let's see what we can do. And you can also have like a bunch of, like there are ways to, oops. There are ways to game this system, I guess. Man, it's gonna be really cool once like there's screen wrapping and stuff. Oh, whoa. So eventually I'll hit something and die. Okay, well, that's it. That's pretty much everything I wanted to do for this video, for the stream. In tomorrow's stream, we will be working more on this asteroid game. The overall plan for it is that I kind of want it to be like a roguelike asteroid game. So the idea is like after we polish it up, after we make the basic asteroid game, we'll add cool things like a power up every time you kill 100 asteroids, and maybe we'll add like enemies, ships. Like I've seen some versions of asteroids use ships, so like little alien ship, and so let's see, maybe we can find some little alien ships, but like we could do a lot of cool things. So I have a lot of ideas of how to improve the game, of what to do next for it. Specifically, I want to get the asteroids to look more asteroidy, like more like messed up. I think we could do it pretty easily. Like I have a way in my head that we can do it. It'll just make collision detection really difficult, but we will make sure that collision detection is a lot faster if it ends up being slow because of the way I'm doing it right now. But yeah, okay, so thank you everyone for tuning in. I will be back tomorrow at 7 p.m. EST. And if you want to continue on working on this asteroid game with me, that'd be kind of cool. Otherwise, yeah. Cool. Have a good night, guys. Take it easy.